Hey, what's up, guys? This is Chung here. So today, let's take a look at LeetCode problem number 739, daily temperatures. It's a very classic medium problem. We're given like a list of daily temperatures T. Returns a list such that for each day in the input tells you how many days you would have to wait until a warmer temperature. If there's no future day for which there's a, this is possible, put 0 instead. So for example, right, you have a temperature of 73, blah, 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 and then at days number one, so you have to wait for one day to get a higher temperature. Same thing for 74, you need to get like 75, right, one day. And then for 71 here, you have to wait for 1, 2, 3, 4. You have to wait for 4 days to get a higher temperature, so on and so forth. And there's some like constraints here. So for this problem, the brute force way, well, of course, is for each of the elements here, for each of the temperatures, we just loop through all the temperature starting from this day, right? And then whenever we find the first temperature, which is higher than the current one, we just return the difference between those two indexes. And of course, that's the time complexity for that is just like O n square, right? Since for each of the elements, we'll be searching the whole array here. I mean, so how can we improve that, right? So a common approach for this kind of problems, first thing is if we can sort it, right? If we can sort it, and then we can probably use a two-pointer or binary search to improve the performance. But I think for this problem, we cannot sort it because the sequence matters, right? Because we have to find the temperature after the current date. That's why we cannot sort it. And if we cannot sort it, then what can we do to improve the performance, right? And then still, right, maybe we can try to do a binary search with the current temperatures. Maybe we can see. Probably not, because even though for binary search we still need a sorted array, but this one is not sorted. Then the last resort will be what? The monotonic queue, right? So, and for this problem, that's exactly what we're going to use here. So the monotonic queue, like I said, it's a great use tool to help you reduce the time complexity from O(n) to O(1). And for this problem, how can we use the monotonic queue to help us solve this problem, right? So if we think it in a reverse way, instead of looking forward, we're trying to look backwards, which means that at the current ice day, we look back. We look back. If there's any temperature which is smaller than the current temperature, if it is, then we know, okay, I'm the first warmer day for those temperatures. So we can just set the values. So we can set the answers for those temperatures, right? And as long as we set the temperatures for those values, we don't need those temperatures in the waiting list anymore, because we know the since we are every time we'll be doing this check here, we know the current ice temperature will be the closest warmer day for those answers. And because every time we'll be popping those things out, those day temperatures out, so we're making sure the ones on the have been set already will be removed. And since I will be popping those calculate the result out every time when we find a warmer day, the total time complexity for this problem will become to n plus n, because it will be uh, assuming we have a decreasing Q here, and we'll be appending and popping each of the temperature into this decreasing Q only once. So that's that's why the total complexity will become to On here. Okay, so to code this one real quick, the n, we have answer, right? Answer is like what? We initialize everything with 0, right? And then we have n here, and then like I said, I'll be having a decreasing Q. So for example, we have 73, right? So this is a decreasing Q here. And by the way, we're storing the index, not the values, into this decreasing queue. So the first one we have 73, which is index 0, right? And then we have 74. We check if the current temperature is higher than the top one on the queue. If it is, and then we update our answer. So let's say we have answer equals to 0, 0. We have like 1, 2, 3, 4, 5, 6, 7, 8. We have 8 zeros to start with, right? So now we have 0. We have 0 temperature, 0 index in the decreasing queue here. Now we have a what? We have 74. And 74 is what? It's greater than 73. Then we know, okay, cool. So we find so for this 0, the 74 will be his closest warmer day. So that's why will be we'll pop these things out. Okay, we'll pop it. And while we're popping it out, we'll also update the answer, right? Because we have found the answer. So now this one will become to 1, right? And then we're inserting the 74, which will be 1 in this case. Same thing for 75, right? So for 75, okay, again, right? We pop these things out. Now this one has become 1. Now we have 2 here. Now this one is gone. And now we have 71. So, and is 71 greater than 75? No, right? Then we just keep appending, pushing it into the priority queue. Not priority queue, the monotonic queue here, the decreasing queue. Because the 3 is smaller than 2. That's why we haven't find a warmer day yet. Same thing for what? Same thing for for 69, right? 69 is smaller than the 73. So we have 4 here. And then, oh, now we have 72 here. So 72 is greater than 69. 69 is like 4, right? That's number 4. That's why we pop these things out. We pop this out, and then we use the current index minus this index will be 1. So that's why we have 0, 1, 2, 3, 4. That's why we have 1 here. Okay, and then we continue comparing it. It's now the 69. This is 69, right? So 69 is also smaller than 72. Sorry, 71. Sorry, this is 69, and this is 71. So 71 is also smaller than 72. So we keep popping these things out. And now we have what? We have this one, right? So 5 minus 3 is equal to 2, because we have find the closest warmer day for the index 3 here. That's why we have 2 here. And so continue. Well, now we have 72 here, right? So we have a 5 here. 5, this is 72. Now the next one is 76. 76 is greater than this one, so that's why we have 1 here, right? And then 76 is also greater than 75. So 6 minus 2 is 4. That's why for the number index 2 here we have 4, right? And the rest are 0. That's how we use this monotonic queue, to maintain a candidate that has not find a warmer day yet. As long as we find the first warmer day, the warmer day, because we'll be popping that things out. The reason we can pop that things out is because it's already the moment we find the first warmer day, then the current one will be popping that out. And since it is a decreasing queue, and the moment we the moment we cannot pop that out, we know okay, so all the remaining temperatures in this queue will be all higher than the current one. So we can just leave that. We can just safely push the new temperatures into this queue. Okay, that's how we use the monotonic queue, right, to improve the performance. Okay, so let me finish this implementations real quick here. So like I said, we have a for I in range n here, right? So like I said, while the decreasing queue is not empty, right, and the current temperature is greater. So keep in mind, this has to be greater, okay? It cannot be equal. Then the what? Since we are storing the index, we have to use the index to find the value for that the top element, right? And then we have a previously I here, right? And then we have a decreasing q dot pop. So we pop that out, and then we can update the answer. So the answer is the pre I, right? And the value is the I minus pre I. So okay, and we simply return the answer. Oh, sorry. So I forgot to add that to append the current index to the queue. Okay, and actually, putting the index into this into the queue is sometimes a very useful skills or technique. Instead of putting the values. Even though for this problem you have to use the index because we need the index. But sometimes if you can put either the values or index into the either the list or the queue, try to think of index. You may find it's very useful. Okay, cool. So let me run the code. Decreasing queue. Okay, so there's a typo here. All right, cool. Submit. Cool. So yeah, and as you guys can see, so the total time complexity is O of n, right? Because here will only be popping and appending the element, each element into this queue only once. So that's that. And solution. There's another solution for this problem. Basically, instead of looping from the beginning, we can also looping from the end. So so the intuition for looping for traversing from the end is mm, is in a reverse way. Basically, every time when we see like smaller numbers, basically we'll be popping all the numbers in the current queue, which is smaller than the current numbers, equal or smaller, until we have reached a bigger number, right? Then we know, okay, that number is the one that number is the warmer day I'm looking for. So since we are looking for the warmer day, right? So for this one, the first approach, actually from the current one, we're looking for the first, I mean all the cooler days than the current temperature. And if we're traversing from the end, we're essentially looking for the first warmer day, for the current one. And since that's for that case, we have to record all the days that after the current day. That's why we have to loop through in a reverse way, right? So we have a n minus one, minus one, and minus one. So like I said, so if the still so similar like this one, and if the current temperature, right, is either equal or greater. So keep in mind we have an equal or greater here because because we're looking for the first day that which is warmer than the current temperature. So we don't want the day with the same temperature. So here we just pop that out. Here we don't have to worry about, we don't need that the index here. So all we need is the index which is higher than the current one. And in that is actually if the has anything left in the decreasing queue, and the answer of I will be what? Will be the decrease will be the top element in the decreasing queue, right? So because this one at this time, so if there's anything left in the decreasing queue, the this one is the first temperature, right, which is higher than the current one, because we have popped all the temperatures, which is smaller, equal or smaller than the current one. Okay, and that's why we have these things minus I, similarly, right? And then we return the answer. And of course, how can we forget appending the element, right? Cool. So this should also work. All right, submit. Cool. Yep. So that's another thinking process, right? This is the from start to end. This one's from end to start. Either way it works, you know. Cool. All right. I think that's it for this problem. It's pretty straightforward. It's just like a good practice for monotonic queue. I hope you guys like the videos. Like this video? Okay, and thank you so much for watching it. And I'll be seeing you guys soon. Bye bye.